Today you have an assessment on balanced and unbalanced forces. Let's achieve 70% or greater on your test. Your starter reads, according to the data table, how much force is acting on the cart when the student measures an acceleration of 2.6 meters per second squared. Now in this chart, what you see here is your forces, that's what's given, and your acceleration. But here they're asking you how much force is acting on the cart when the student measures an acceleration of 2.6 meters per second squared. So first what you want to calculate is the mass of the cart. So in order to find out what the mass of the cart is, don't forget your formula triangle. You're going to cover up the variable that you need to find, which is mass, and your formula reads force divided by acceleration. So once you have mass equals force divided by acceleration, you're just going to simply plug in any force number, like 1, and then the acceleration of 0.2. If you divide that, the mass of the cart is 5, we could say kilograms. Now, the mass of the cart doesn't change. So if you divide 2 divided by 0.4, you're going to get a mass of 5. If you divide your force of 5 divided by 1, you're still going to get a mass of 5. So when you divide force divided by acceleration for any of these, you will see that the mass of the cart is 5. So now that we understand what the mass of the cart is, we can go to our STAR reference guide and get our formula, net force equals mass times acceleration. We can plug in the mass of the cart of 5 kilograms. Our acceleration is now given 2.6, and we multiply 5 times 2.6 to get a net force of 13 newtons. I'm going to do a little practice on using those formula triangles. So what we want to do here is, when we calculate force, the formula is given for us. Net force equals mass times acceleration. So I'm just going to show you how to get this formula into the formula triangle so we could use this as a tool to get a formula for mass and acceleration as well. So here in your formula triangle, you're going to draw a triangle on your paper and place a T in the center. So to place these variables inside the triangle, you're just going to simply read the formula, mass times acceleration. Multiplication always goes across in the formula triangle. So I'm going to put my multiplication sign right here in the middle. So if it reads mass times acceleration, you can get your mass variable and place it, and you can get your acceleration variable and place it. So all I did was simply read the formula that's given to me, mass times acceleration, and I put it in the formula triangle. Now you can place your variable for force up top. Division is always going to go up and down in the formula triangle. Okay? So if your question is asking you to calculate the net force of an object, you're going to simply cover up the variable you're solving for, and your formula reads force equals mass times acceleration. So this is the formula that you would use. Let's go to the next slide, and let's say we needed to calculate the mass of an object. So you're only given this formula, so we need to find a formula for mass. So let's get this formula in the triangle and find a formula for mass. So remember, multiplication always goes across, and division is going to go up and down inside your triangle. We're going to read the formula that's given. It reads mass times acceleration. So I'm going to put my mass times acceleration. Okay, and then my force would just go up top. Okay, so if I wanted to calculate mass, what I would do is I would cover up the variable for mass, okay, and your formula reads force divided by acceleration. So let me get my pen, because if we need to calculate mass, okay, you want to write mass equals, because we want a formula for it. So your mass would equal force divided by acceleration. So that would be my formula that I would use for mass. Going to the next slide, if you had to calculate acceleration, remember you're going to draw a formula triangle. Multiplication goes across, division goes up and down. Use your formula that's given to you. It reads mass times acceleration, so we want to do mass times acceleration. Okay, and so now you know where to place your force. Your force just goes on top. And if we want to calculate for acceleration, we're going to cover up our acceleration variable, and our formula reads force divided by mass. So let's get a pen and write that. So if we're calculating acceleration, we want to do a formula. Acceleration equals what? Acceleration equals force divided by mass. Now I have a formula for acceleration. So on today's assessment, I highly recommend drawing a formula triangle. Get your formula for net force into your triangle, and then use that formula triangle to get a formula for mass and acceleration. So your test is on unbalanced and balanced forces. How do balanced and unbalanced forces affect an object's motion? Remember, balanced forces, you're going to have objects that are at rest or in a constant speed. They do not change an object's motion. Where unbalanced forces are the opposite. They change an object's motion. So the object will be increasing speed, decreasing speed, or changing direction. How are force, mass, and acceleration calculated? We just went through the formula triangles to calculate force, mass, and acceleration. What is the relationship between force, mass, and acceleration? So if we look at that formula, net force equals mass times acceleration, remember the greater the force, the push or pull applied, okay, the greater the acceleration. So also if the mass of the object is large and the force is held constant, your acceleration is going to be small. If forces are held constant and the mass of the object is small, you're going to have a great acceleration. So your assessment today is on demonstrating and calculating how unbalanced forces change the speed or direction of an object's motion. You have 10 questions. Please click on the video to watch how to access a test on CMS if you're not sure. This is your test code here below. You'll need to use your STAR reference guide for your formula chart.